Hello everyone. The title of this video is Use the Change of Base formula. Every exercise I'm going to do in this video is taken directly from a free online textbook at openstax.org, and I'm in the Intermediate Algebra 2nd edition text in section 10.4 titled Use the Properties of Logarithms, and I'm under the heading Use the Change of Base formula. And in these exercises, I'm only going to do the even numbered ones. So 278, 280, and 282. Right, just those three. These are the ones that don't have a link to the solution. Right? The odd numbered ones actually do have a link to the solution. I will also have timestamps for when each exercise begins in the description of the video. So you'll see example 1, the timestamp for when 278 begins. Example 2's timestamp will be for when 280 begins. And example 3's timestamp will be for when 282 begins. I also request that when you're working on this, watching this video, and I bring up a new question, pause the video and try to work it out yourself first before you watch me do it and then compare. Because if you're just watching me do these questions and not practicing yourself, chances are you're not going to learn all that much. Alright, so in each of these exercises, we're asked to use the change of base formula to evaluate, to find the values of these logarithms. And we're going to round to 3 decimal places, right? Round to the nearest thousandth to approximate each logarithm. Alright, so we're starting with 278. I have these written out on paper. So example 1, number 278 in the text. What is the log base 3 of 42? The log base 3 of 42. Alright, so we can get a rough idea. Now, I know we're going to use a calculator in a second, and I'll get into what this change of base formula is. But we know that, here are some powers of 3. 3, we know that 3 to the third is 27. And 3 to the fourth power is 81. Right? And 42 is in between those. Right? 42 is in between 27 and 81. So I know from this that the log base 3 of 42 is going to be between 3 and 4. Remember, logarithms are exponents. 3 to the third, 3 is the log base 3 of 27. 4 is the log base 3 of 81. So the log base 3 of 42 is going to be between 3 and 4. So I can at least say that much before we get into this change of base formula. Alright, so 3 to the 3 point something power will be 42. Alright, so let me talk about the change of base formula. And I got a separate page here. And I'm just going to write it out. Alright, and I'll show you the little proof of it as well, and why it works. So if you start off with an expression in base b, so say I take the log base b of some number, some positive number, m. Alright, so this side we're in base, b, whatever b is. Well, say that's not a nice number, like the log base 3 of 42, right? 42 is not a nice power of 3. We can actually change this base to any other base you want. So let's say log base, instead of taking the log base b of m, we take the log base c of m. So over on this side, this is base C. Now you can't just do that and have them be equal. Right? This isn't totally true just yet. But first I change the base to the base that I want, and then you have to divide this logarithm by another logarithm with this new base, right, base C, and the argument of this logarithm is going to be the original base. So I got B down here. Right, so the argument of this denominator logarithm is the original base. Right? And these are the new base that you change it into. But this is called the change of base formula. Alright, and usually it's specifically used to change things with a base of b into base 10 or base e, right? The common logarithm or natural logarithm, right? So specifically it's used very often this way, so that you can actually use most calculators have a log base 10 button or a log base e, right? The natural log ln, that button. So usually it's used this way. I take the log base b of m and I change it to log base 10 of m, but then divide that by the log base 10 of, the original base b. Right? So this is, base 10 here. Or, again, you can change it to any base you want. Notice I changed from base b to base c. Right? You can change it to any base you want. So either they'll do it, usually they'll do it in base 10 or base e. Right? The log base b of m is the natural log of m. Right? Change it to log base b of m, but then divide it, by the log base e of the original base, right? The natural log of b. And here's the same formula, but with base e. Right? Remember e is that 2.718 ... number, sometimes called the natural base. All right, now why does this work? All right, before we get into our questions, why does this work? All right. So again, say we're asked to take the log base b of m, and I don't know what this is. All right, say we don't know the value. It's equal to question mark. Or you can call it x or something. Right? I'm just going to use question mark. Well, change this to its equivalent. Hopefully you know how to do this, right? You should be able to go back and forth between logarithmic form and exponential form. Right? Let's change this to the equivalent exponential form. So b to the question mark power, right? B to some power equals m. All right, and then what I'm going to do is I'm going to take a look at the log of this b to the question mark. All right, let's look at the logarithm base c. Right, so I changed from base b to base c. Let's take a look at the log base c of this b to the question mark power. Well, if b to this question mark is the same as m, right, then this should be equal to the log base c of m. And then I can apply the power property of logarithms. Now, I've written this out before in a previous video here. These are the properties of logarithms, right? Product, quotient. Remember, there was this power property of logarithms. I can apply the power property to this logarithm on the left side here, right? I have the log of something to a single power, this question mark power. Pull the question mark out. We got something, right? The question mark times the log base c of b, right? The power got pulled out, equals the log base c of m, and then I would divide both sides. To get the question mark alone, I would just divide by this logarithm. So we have the log base c of m divided by the log base c of b. And what was the question mark again? Remember, the question mark was my original value, the log base b of m. So we get our change of base formula, right? The question mark was the log base b of m. All right, so the log base b of m is the log base c of m divided by the log base c of the original base b, right? There's a check on that. So that's why this is working. All right, hopefully that made sense. I know it was a lot of letters and stuff. You really don't have to worry about how it works. Just know that it does and use it. Right? And again, I'm gonna more often than not use base 10 and base e when I change from base b to base something else. We'll change from base b to usually base 10 or base e, and it really doesn't matter. Right? I'll show you with a calculator. It doesn't matter. Both work. It can be any base you want. All right, so keeping this in mind, we're asked to find the log base 3 of 42. All right, 3 to what power is 42? Now I know it's between 3 and 4, but we can get a calculator to make it more precise for us. So here this is base 3. Let's change it to base 10. Why not? So instead of the log base 3 of 42, let's take the log, base 10 of 42, but then you have to divide by the log base 10 of the original base, and the original base was 3. And let's see what we get. And we're asked to round this to 3 decimal places, right? So I'm going to pull up a calculator. I have a TI-84 Plus emulator. And let's see. We'll take the log base 10, right, just the log button, of 42, and then divide that by the log base 10 of the original base. Right? And as I said a minute ago, right, this should be between 3 and 4. And look at that. This is approximately, if I round to 3 decimal places, the nearest thousandth, 3.402. 3.402, right? And that's what they're asking me to do right here. Now, like I said, it doesn't have to be log base 10. You can change the base to any base you want. So I could have done, instead of the log base 3 of 42, I could have done the natural log of 42. But then again, you gotta also divide by the natural log of the original base. And what you're going to notice here is that this gives me the same value, 3.402. And like I said, it doesn't matter what base you change it to. I could do, instead of the log base 3 of 42, I could do the log base 5 of 42. But then I got to remember to then divide. Oops, let me delete this. Get out of there. But then I got to remember to divide by the log of that new base, right, log base 5 of the original base, which was 3. And again, you're going to see 3.4021. It doesn't matter what base you change it to. So usually base 10, base E are easier because most calculators have a log base 10 button, LOG, or a log base E button, the LN. Alright. Great. And let's check that. Let's take 3 raised to the, I don't have the whole value up, but 3 raised to the 3.402 power. Alright, now this was rounded, so this won't be exactly 42, but it should be really close to 42. And look at that, 41.99. That's basically 42. Alright, so that was good. Alright, that was good. A good approximation of the logarithm base 3 of 42. Alright. And I'm doing the same thing for all these exercises. So example 2, exercise 280, same thing. What's the log base 12 of 87. Now, even before I go to the calculator, I like to think about what whole numbers or what integers is this going to be between. Think of the powers of 12. 12 to the first power is 12. 12 to the second power, 12 squared is 144. And my argument here, 87, right, 87 is in between these, right? So the logarithm of 87 base 12 will be between 1 and 2, right? Between the, remember, logs are exponents. So this is going to be between 1 and 2. All right, so 12 to the 1 point something power will be 87. All right, so now let me actually use the change of base rule, right? The log base 12 of 87. Again, it's base 12 right now. Let's change it to base e this time, right? So I'll do the natural log base e of 87 instead. But then don't forget to divide by that same log, the natural log of the original base. So I'm going to punch in the natural log of 87 divided by the natural log of 12 in my calculator. So natural log of 87 divided by the natural log of 12. And it's about 1.797 if I was rounding to the nearest thousandth, right? 3 decimal places. This is approximately 1.797, which is like I said it was going to be, right? It's going to be between, I said it was going to be between 1 and 2, which it is. And there we go. And let's check this, right? Take 12, right? This is the log base 12. Take 12, raise it to the 1.797 power, and this should be about 87, right? It's a rounded number, so it should be close. And see, 86.95, that would round to 87 if you were rounded to the nearest whole number. So this is a good answer. Wonderful. And I got just one more of these, so I'm doing the same thing for each of them. All right, so this is the log base square root of 2 to the 17 of 17. And the log base square root of 2 of 17. So remember, square root of 2, to the first power is the square root of 2. Right? The square root of 2 to the second power is just 2. The square root of 2 to the fourth power would be 2 squared, would be 4. The square root of 2 to the sixth power would be 2 cubed, would be 8. The square root of 2 to the eighth power would be 2 to the fourth, that would be 16. And the square root of 2 to the 10th power would be 32. Alright. Now 17 is much closer to 16 than it is to 32, but look, at my argument for this log is between 16 and 32. So this is going to be between 8 and 10. At least at first glance I can see that. Between 8 and 10. And because 17 is so close to 16, I think the power of this exponent, this logarithm here, is going to be really close to 8. I feel like it's going to be 8 point something. So the square root of 2 raised to the 8 point something power will give me 17. But let's actually do it. All right, let's actually find it out with the calculator. So we have the log base, square root of 2 of 17. This has a base of the square root of 2. Let's just change the base. And again, I'll just change it to base 10 again, right? So let's do the log base 10 of 17 instead. But then don't forget to divide by that same log, right? Log base 10 of the original base, right? Of the square root of 2. Okay. And I'll punch that in and we'll round this to 3 decimal places, right? Round to the nearest thousandth. Alright, so I'll pull my calculator up, do log base 10 of 17 divided by the log of the square root of 2. Yeah, see, it's 8 point something, like I thought it would be. 8.175, right, if I was rounding to the nearest 3 decimal places, the nearest thousandth. And there we go. And then let's check it out. All right, let's take the square root of 2 raised to this number, and it should be about 17. Right? So the square root of 2, get out of there, and then raised to the 8.175 power. And this should be about 17. Right, so very, very close, 17.000, right? That would definitely round to 17 if you were rounding to the nearest whole number. So it looks like our answer is pretty good. All right, great, and that's it, right? I'm doing the same thing, all these, right, using this change of base formula, right, but using either base 10 or base E just to make it easy on a calculator. So yeah, so just change the base, keep the same argument, and then divide by the log with this new base of the original base, right? The argument in the denominator logarithm is the original base. Wonderful. All right, and that's it. All right, so I'm hoping that watching me go through these 3 examples here helps you in some way when you're asked to evaluate a logarithm using the change of base formula on your own. All right, and thank you very much for watching.